Is that one time or two times? That's two times, right? What do I do when I have two times? Do I add them? Do I subtract them? What do I do with them? I don't add them. I do what with them? I subtract them. So I take the, what was it, 10 and 5? 10 and 5. So 10, subtract 5. Now, do I have distances given to me in question number 3? No, I don't, do I? So where am I going to get the distances from? From the table. So find the 5 seconds. What number matches the 5 seconds? So I'm going to put the 30 right above the 5. Now find the 10 seconds. What matches it? So I'm going to put the 70 right above it. Now, what do I get when I say 70 minus 30? And 10 minus 5 is 5. So 40 divided by 5 is 8. If you don't know it, it's not a problem. Use your calculator. Okay? Now, number 4. You're finding average speed. Where did I tell you yesterday and just a minute ago in the opening to look to get average? What's the total distance Jack ran? You ran how far, Maria? You're looking at the same question I am. Oh, 120. Sorry, I'm looking at the wrong column. Yes. 120 meters. Over, what's the time? 20. I was looking at the wrong column. Miss Wall would have done the problem wrong. All right, so 120 over 20 is what? 6. Now, the next question asks you if this is constant speed or average speed. How do you know the answer?
Constant is a straight line.
Okay, you could graph it, or you could look at your 2 answers. What can you tell me about this speed and this speed?
They're different.
They're different. So if those speeds are different, what do you know?
It's different.
It's average.
It's average speed. Okay? Questions about that? Just go to the hallway. All right, number 6, 7, and 8 are a graph. Let me pull up the Elmo to do that one. That way I can draw the graph. All right, the graphs, State likes graphs and tables, which is why I try to put graphs and tables in a lot of stuff that we do. So,
It really made you yeah. Yeah. I heard Mr. George in a real funny side. Mr. George goon. All
right, is that big enough y'all can see it?
Mm-hmm.
All right, so question number 6 says, where on the graph is the object not moving?
15 to 30.
All right, so 15 to 30. So here, yep, I agree that's 15.
Don't understand that, right?
And yes, so not moving is 15. Oh, you can't read that. So yes, it's a 30. So if you wrote it down, 15 to t equals 30 would be correct. Okay? Does everybody understand why it's not moving? All right? When it says to you, not moving, you're looking for where the line is flat. That's the piece you're looking for. Okay? You're looking for where it's flat. Nisha. Right here. You said 10 and 30? Okay, 10 is more right here, which is still going up a little bit. Class providing you behave.
Can you turn it off?
Can I turn it off? You can turn it off. That way you save your battery power. It's turned off. All right. Number 7 wants to know what speed do we have between 10 and 60? All right, so how many times do we have if we've got 10, whoops, I'm a little over too far there, 10 and 60? All right, how many times do we have between 10 and 60? How many times is that? So what do we do if we got 2 times?
Subtract.
Subtract.
I did not know you could multiply times.
You're not ever going to multiply the times. Every time I ask you this, when you've got 2 times, the answer is always going to be what? Subtract them. Okay? Just like in the last unit when we did densities and you had 2 volumes and I kept saying, what do you do with the 2 volumes? The answer was always what? What was it, DeMarco? Subtract. So when I say you've got 2 times, what is the answer always going to be with the 2 times?
Subtract.
Subtract. It's not going to change. Okay? So we took the 60 and the 10 and we're going to subtract them. The problem we have is, what don't I have right here in this question? A distance. That's the piece we have to read off the graph. Okay? So now we got to go to the graph. So find the 60 down here on time. Okay? So 60 is right here, right? Read up to the graph and read over, and it looks like 20, 40, 60, 80, 100, 110. Yes, ma'am.
Go ahead, Carlos, for just a minute.
It's a Friday. He's apparently not a regular Friday attendee, so he's not here.
Lovely.
Okay.
Thanks.
Welcome.
When she got here her day, she was like, huh? She's like, oh.
There used to be. They just have to wait. Oh. All right. So.
That's not 110. That is 100 and freaking 8. 108.
Well, I'm just estimating 110. We can go 108 if you want, Devin. I was just trying to make it easier and go 110.
Because Maria wants to do it.
Okay. Y'all put 107 and 108. I was trying to make it on the line. All right. So find 10. And then 10 and up looks like what?
30.
30.
Or is it 40, Maria?
Really? All right. So what do I do with those 2 numbers? We subtract them. So 110 minus 30 is 80. 60 minus 10 is, so 80 over 50 is, y'all got the calculators, I don't. Well, I got some pen in my pocket.
1.6.
1.6.
Might need that pen.
All right, meters over seconds. Now,
So you're not trying to give me that pen?
the last thing is it wants average speed of the graph. Where would you need to go on the graph to get average speed?
Oh. The highest point on the graph.
Okay, not necessarily the highest point, but you're very close.
The middle.
Not the middle.
Side.
The end, the very end of the graph.
Yeah.
Okay, so go all the way to the end.
That's the highest point, right?
Well, on this graph, it is the highest point, but what if it went down?
Oh, see, now if it went down, I wouldn't.
Okay, all right, that's why I wanted to clarify. Okay, but in this case, the highest point is right for Drew. All right, but if the graph had gone down, you couldn't necessarily say the highest point.
Is it the graph?
Okay, so the end of the graph. So if we read down without somebody telling me it's not quite on the line, speed equals distance over time. So what's the time?
80.
80 is the time. Now my people who are reading my distance,
130.
what you got?
125.
All right, hold on. This is reading in what? Is it reading by 5s or by 10s?
10, so it's 130. 130.
It's 130. So what's 130 over 80? Y'all got the calculators, not me.
1.625.
All right, so let's round it to 1.6 meters per second.
It didn't change.
It didn't change in average versus what we did a second ago. So it's pretty close to what I had you do in B. Questions? Any questions? All right, we're going to try a little bit of a graph, and then we're going to do a little bit of notes, not many today, and then we're going to do it live. The notes today are pretty short.
We start the last before 1 o'clock.
We need to start the lab well before 1 o'clock. You're not getting along with this activity. Now, the biggest problem you guys have when you go to lab is you talk too much, and then you don't get done. You gotta talk less about stuff that has nothing to do with what you're doing. And I can't fix that for you. When you go to the counter, or in this case, you're gonna be more on the floor today, you're gonna have to work more, talk less. Now, this is very short. You have 7 questions. I want you to do as many as you can before I stop you. I'm going to give you about 10 minutes. Just take the best, you
Oh!
Yes, younger end.
That hurts.
All right. Now, see how some of us are slow to start? This is why we don't finish things. You just sit there.
Start now.
Yes.
Don't start without me.
You don't have time to wait on DeAndre to get back. Answer what you can. I'm going to roam around and help some of you. In just a second, I'm just putting my paper there so I have it when we're ready to go over it.
Miss, do we have to figure out what's speed?
Yes, you do. Some things won't ask you to calculate speed. Some will just ask you like distance or time. But a lot of them are going to ask you to calculate speed.
Let's see, it's how far.
So that's just distance. But this is asking you to read a graph. So if it says how long, it's asking for time. What? How far would be distance? Yes. Hang on, let me get the marker on. I'll be over there in a minute.
All right.
What is it? KM? KM?
Yeah.
Is this where they, 0.5?
That's where they met. That's where they started at when they met. Before they met would be here down. So it would be from my pencil down would be before they met. The lines are set. All right, so you would be talking. Why would they do that? Yes. That's quick.
It's like this.
40 copies left of course music. So
Oh.
you just empty.
Goes from 20 to 40 since it's distant.
Yes.
It's basically 20.
Yes.
So I was like, all right.
All right, how about over here? Anybody got a question on this side?
Yeah.
Yeah. Where, which question you doing?
He's gonna calculate.
Which one's?
Same attachment. How long
When
will
we
you
did
time?
that.
So from 0 to.
63.
That's my.
That's what I was questioning. It's long. I've been asking you that one. Okay. Car A is asking for its speed, so once you calculate car A's speed, so pick 2 points on car A's line and calculate its speed. What? Yeah. How long have they been traveling before they met? You're talking from here to down. So you're talking there, because the lines are separate.
Okay, no.
We'll shut up.
Did you close your roll down over there?
Tell me, sis.
Something dumb down. They gave me some knowledge in this, bro. I feel like a grown up. This year? Like, it's my last year. This year and next year, bro.
All right, let's look at some of what you came up with.
I don't.
You're gonna mess up.
All right, question 1. Some of you have the right answer, some of you don't. Question 1 says, how far did car A travel before it met car B?
39.
All right. Some of y'all looked here and said it met there, and you read across, and you said it drove 40 kilometers. You did, and it's not right. Now, car A did not travel 40 kilometers. Car B drove 40 kilometers because it started at 0 and it drove to the dot.
Car A only traveled 20.
All right, car A, which is what the question started with. How far did car A travel? All right, where did car A start at?
20.
Car A started right here at 20 and it drove to where?
Oh.
40. So what are we going to do if car A started at 20 and drove to 40?
20. Subtract.
We're going to subtract. So on that first line up here, you should have said 40, subtract 20 equals 20 km. And that's an easy mistake to make. You don't have to write all that. The answer is 20 km. Okay? I'm just showing you where it came from. You will see a graph like this on the next test. That's why we're going through this. Graph reading is part of the exam. They love graphs and tables. Number 2, how long had the 2 cars been traveling before they met? Now, you've already put the dot there for where they met, right? Most of you looked down and said, oh, that's where they met at. But then you struggled with the estimate. What would you estimate that at? Okay, 0.5. Now, you can write 0.5 hours is fine. Or some people said 30 minutes. Either answer is completely cool. 0.5 hours or 30 minutes. Most people wrote 0.5 hours, but I did see an occasional 30 minutes out there. Now that we've done number 1, how would we do number 3? How far did both cars travel at the same speed?
Subtract 80, subtract 40.
All right, so can we agree that they travel at the same speed from this dot to right there? Can we agree on that? So, if I look at, can we agree that they travel at the same speed along that red line?
Yeah.
All right, so start at?
40.
And where did they end at?
82.
So how far did they travel at the same speed? 80 minus 40 is 40 kilometers. Now, how long did it take both cars to get to point C?
An hour.
2 hours.
Now, I think this question is a little vague myself. Are they saying, are they asking you, how long did it take both cars to get to point C, traveling at the same speed? Or did it just ask, how long did it take them to get to point C? I think it's a little vague. So it depends on how you read the question. I read it as, they're just asking you, how long did it take them to get to point C? How long did it take the cars to get to point C? That's the way I read it. I read it as it took it an hour and a half to get to point C. Now, if you read it as they're still traveling at the same speed from question 4 or question 3, I can understand that. That's why I said I think it's a little vague. And if you put an hour, I would not have marked that wrong because I think the question is vague. Yes, you may. I don't want you to choke me. Now, which one of these cars are traveling at constant speed? All right, now. Because why? That's exactly right. Which one is completely straight and diagonal? Car A. Car A. Car A is the only one that is completely straight and diagonal. If you look at B, it goes this way, and then it goes this way. Is it straight? No. Or I can do it better with pencils and pens. All right, when you look at that, is that straight?
That's average.
That's average. It's not straight. That's why B is not a constant speed graph. Now, this is the part the students have the hardest time with, is finding the speed of A and B. Okay? Now, to find the speed of car A, we need to pick 2 points on the graph and find its speed.
40 and 0.5.
Okay? It doesn't matter which part you pick. Pick 2 points.
40 or 0.
Okay? You can pick any one. Now, the thing I would tell you is, don't pick a line like, or a spot like this is in the middle of a crosshair. I would pick something like this, or something like this, or something like this, where you have a number that's on a spot where they're easy to read. Okay? So, I'm just going to pick this beginning one and this ending one. I'm going to pick the first 2. So, I've got a point of 80 and 1.5, and I've got a point of 20 and 0. Now, did you have to pick those same points?
No.
Absolutely not. Okay, I just picked, that's fine, you can pick that. Okay, I just picked the beginning and the end of the line. Why can I pick the beginning and the end of the line? Why does it not matter where I pick anywhere on the line? Because it's
straight.
It's a straight line. Okay, so what do I do with my 2 distances? What do I do with my 2 distances?
Subtract them.
That's right, I subtract them.
Subtract them. Subtract them.
It's okay, he's close enough. 80 minus 20. What do I do with that 1.5 and 0 time? Subtract them. So I get 60 over 1.5. All right, somebody divide that for me. I can't do that in my head.
40.
Okay, 40. All right, so we get 40 kilometers per hour. Now, the second one there, number 7, asks for both answers. We're going to cheat. I know I'm all about some cheating and some easy work. What do you know about the speed of car A and car B right here? Are they the same or are they different?
Same.
So car B's answer right there is what?
40.
Ding, ding, ding. So we just solved half of our work. Now, what part of the line have we not done? We've not done this part of B right here, right? We got to do that part. We got to do this part right here. So, we need some points. Now, we can do any point you want. I like the beginning and the end.
I did the intersection.
That's fine. You can. So, what point is that? 40 and what else?
0.5.
0.5.
Oh, I did this one already. It's gonna be 80.
All right. What's this point right here?
0.
And?
0.0.
All right. So, what's my distance? 40. Subtract. What's my distance?
0,
Over. What's my time?
0.5.
Whoops. I wrote it wrong. 0.5. Subtract 0. So, what do I get when I divide?
80.
I got 80. So there's my other speed. Questions about how to read a graph?
No.
Now, we'll do some more stuff with graphs over the next couple days. But that's just a basic review to help you with graphs. Questions? Now, find your notes. We're going to talk about velocity real quick, and then we're going to do the lab. So what? It is a Friday.
Where the little tasty?
Where'd the what go? You think he's done now?
Oh my God.
You think he's done? You think he's done?
I don't know, I was gonna check.
You just go back there and hang around.
I
and
told
make
him, I
it
said,
quick.
I'm just gonna hit that interrupt button. It's like, don't do that.
Oh.
All right, find your notes. We're going to do a couple things on velocity, and then we're going to do the lab. Today's day. Today is the 8th. Today's the 8th. All right, velocity. Now, this is a word most of you have probably heard before. Where to put the pen? There it is. All right, velocity is defined as speed with direction. Okay, it's speed with direction.
So like, what, 80 miles east?
That's right, 80 miles an hour east. So, how is velocity different from speed is what Drew just said. It always gives direction. I'm going to put an example up here. For example, it might say 85 miles per hour east. Whereas yesterday, when we were talking about speed, it only said 85 miles per hour. In these problems, it will always specify a direction. Right? Like when we were doing displacement. It said blocks east, it said blocks north, whereas with distance, it didn't matter. But with displacement, it had to give us a direction because displacement is a vector quantity. It specifies the direction you travel. Velocity is also a vector. It has to specify direction. The nice thing about velocity is the work and the calculations work the exact same way. There is absolutely nothing different about the formula and the way it works. So that's the nice piece about the formula. Oh, we got one more. I'm saying Carlos was here.
Oh, me too. I made one. I don't know, the 10 shot. But that was a 3-point.
Oh, was that?
Yeah. Yes, I'm gonna call you.
Now, put your name on these so that if you leave it laying in here, I can get it back to you. Now, this is a reference table. We're going to use it all semester. You may use it on every test and every quiz, providing you don't just take notes on it and write down stuff you're not supposed to have. I told you this day one. The state is going to let you use this information. They're going to give it to you on some nicer paper than this. This is on cardstock. And it'll be a booklet when you get it on the exam because you'll open it up and it'll be a giant,
pretty nice.
it'll be a giant periodic table inside. This is the front cover of the booklet. This is the back cover of the booklet. And when you open it, it'll be a giant periodic table on exam day. Okay? Now, the very first formula on here is velocity's formula. Does everybody have what they want off the board? Okay.
Oh.
Hurry up.
Oh, wait.
Come on. We're not going to get to the lab at this rate. Come on. It's your time.
It look like this yellow paper can hold it for
The yellow paper what?
it look like it's gonna hold it for
It is. This is on the formulas are only 9 weeks worth. Now, if you forget density, if you look at the very last formula on the back side, there's your density formula.
Oh, God.
On the back, it's the density formula.
We need this.
Okay.
Codes. Right.
Everybody caught up now?
I'm straight now. Hold on.
All right. So the formula. If you look at the front of the paper, it says V equals triangle D over triangle T. Now, you haven't seen me draw those triangles because we don't need them. It's the same thing as writing V equals D over T. All these triangles mean is change in. Now, what have I been yelling about all day? If you have 2 times, what have I been trying to convince y'all all day to do those 2 times?
Subtractive.
If you have 2 distances, what do you do?
Subtractive.
Okay. So that formula, that triangle, is trying to tell you that if you have 2 times, you subtract them. If you have 2 distances, you subtract them. That's what the triangles are there to tell you. Okay? So I don't usually write the triangles because I teach you that stuff. It's just clutter in the formula. Now, does this formula look similar to something we wrote yesterday? Similar to what?
Speed.
Which is why the state doesn't put the speed formula on the reference table, because it's the same as the velocity formula. Okay?
Yeah.
Y'all stop.
Good.
Oh, good, right?
All right. So how did we draw constant speed or constant velocity yesterday?
Constant is straight.
Straight how?
Diagonal.
Straight and diagonal. Now, we can also draw it with velocity. Now, this is where it gets a little more confusing. How do we draw it if I put velocity on the y-axis? How would the graph look different if I put velocity on the y-axis? If I put velocity right here, how does the graph change?
I don't know. I see it's gonna go across. It's gonna be curved.
All right, hold that thought with a curve for 1 minute. We're going to have one with a curve. This one is not going to be curved yet. Velocity is not going to change, right? Constant velocity means it's not going to change. Not straight up. It's going to go straight across. That means velocity is not changing. Now, when distance was like that, that meant the distance was staying the same. This time we're showing that velocity is staying the same. Now, to what Jameer just said, if velocity is going to increase,
Oh, yeah, no curve.
that's going to curve.
Shit.
Watch your language.
I said shit.
No, you didn't. Now, what if I put velocity on here? If I put distance, remember I changed the y-axis. I want to increase velocity.
It's gonna go start down, down.
Mm-mm.
Do that diagonal.
That one's going to be diagonal.
Ooh, like that. That was hard. I didn't see that coming.
Okay. We're going to work more of those on Monday.
All right.
We're going to do more of that on Monday.
All right.
Now, questions. I don't want to spend a lot of time with the math today because we've already spent time with the math. And with the exception of one thing, I can do it on Monday. This. The rule for combining velocities. Okay? Somebody write that down in your notes for me. Tanya, I'm going to make you be it. Write combining velocities down in your notes so you can tell me where I need to pick up. Yeah, combining velocities. That way I know where I left off. And Monday we're going to have to spend some time with some math. Well, there's always the possibility that the hurricane that's coming may knock our power out, but let's hope that's not the case.
Oh,
It smells you up. Well, that's possible. I mean, I don't mind missing school, but I'd rather not do that. My children drive me crazy. What am I supposed to do without internet? I can't charge my phone. What am I supposed to do with myself? It'll drive me insane. All right. Now, everybody chirping. I want you to notice the time. Some of y'all are struggling with this concept. Now,
God.
I'm going to pick your groups today, by the way. First of all, you're going to need a measuring tape. Measuring tapes are 153 centimeters long. That's the distance your car is going to travel, is 153 centimeters. Okay? So when you're measuring distance, did everybody hear me say it's going to travel 153 centimeters?
Yes,
All right, I need 2 volunteers, so hold this on the floor. Find 2 of you. I don't care who. Now, stretch it out on the floor. Now, we have stopwatches. Shh. There are starts and stops and resets. They're not hard to use, particularly if you'll actually read what they say. All of them are in the correct modes. Do not push the mode buttons and you will be fine. I set them all in the right mode, second period myself, so they're set correctly. If you want to start it, hit start, stop, hit stop, and then reset or reset it. If you're not sure, ask me. Now, someone is going to need to time and someone's going to need to pull the car, so we'll go. Please do not rev my cars up and just pull the strings back and forth. They're old. They're about 15 years old, maybe slightly more, and they will break. One fool last semester broke. I told you who, you will all laugh and go, yep, not surprised by that. No. Now, I'm going to make Maria be the timer. See where it says start and stop? Now, someone is going to have to deal with the car. The person that's handling the stopwatch is going to have to say start so that the person with the car knows when to release it, and the person with the stopwatch is going to have to watch when it clears here. Now, you see how Devin's sitting there? This car is going to hit him. Now, it's not going to hit with a great deal of velocity. However, he might want to move over slightly so the car can clear the end of the measuring tape. Because you're going to time from the beginning of it to the end of it, and it's going to veer off somewhere. Okay? So, yep.
Oh, no.
Okay? Now,
It's out. It's out.
Police voice.
Now, on the stopwatch, Maria has a number of. Now, y'all are gonna write this down on your paper, is 1.82 seconds. You do not have to write all that crap from the stopwatch down. 1.82 seconds is fine. Now, you're gonna need to run the 5 trials. Does everybody have an average? Add all of them together and divide by how many you have. Okay.
Can I put the distance in out?
You can, I don't care. All right, my groups. I've got Maria, Haley, and DeMarco. I've got Jameer, Chris, and Devin. I've got Alberto, Nathan, and Louis. Eshawn, Keely, and Jonathan. Timothy, Nathan, Tanya, Drew, Abigail, and Jesus. And then I've got Devin, I'm going to put with them, and DeAndre, I'm going to put with Haley, because I don't want a group of 2. It's too hard to operate the equipment. Now, I need a group up here in this corner, 1 over here in this corner. I can have 2 in the middle area. I can have 1 back there by the computers, 1 back there by the doors. The equipment's on the table. Get going. We've got about 35, 36 minutes to finish. Plenty of time. Don't waste it. Come on.
Let's get it.
Work with your group. Let's go. Hurry up. Take the best. Go quickly.
And they know Haley and
Because
DeAndre.
your group mates are going to struggle to get started without you, just with hands.
Where are the spots that
Up here. You got this one? We already have 2 groups here.
It's so
We already have 2 groups here. Take one in the hallway.
Going all the way, Devin. Tell him, Jameer.
Stay close to my door, though.
All
Right, I was thinking that.
Stay close this way.
It's not about my shoes.
Which group are you with?
Hey, right here.
They go like this. We feel like.
This group is Jameer with.
Me?
Yours and Deb.
Okay.
No, you're not. You're with Jameer and Chris.
Okay, come
You
on,
stop me
y'all.
that.
Come on, y'all.
Birds. Deb. Right there. There's your group mate.
Yeah, I'll take it.
I got time, y'all. Let me get my paper.
Let her time in.